Welcome to the July Self-Driving Cars 101 event. This is our first virtual event, so I want to welcome everyone and just kind of let you know that although all attendees are on listen-only mode, the chat feature is fully enabled, so you can enter questions as you go, and I'll be kind of monitoring that. And we'll try to move through the panel questions quickly enough to save some time toward the end for as many questions as possible. So I promise I will do my best. So we are grateful for Zico Robotics to be hosting this event for us. They have given us access to their corporate Zoom video conferencing system, and that's what we're all enjoying right now. So to get started, I'd like to just ask Yao Zhai, who is the co-founder and CEO of Zico, to just say a few words about Zico itself, and then we will move forward into the panel discussion. Yao, let me turn it over to you for a few minutes.
Thank you, Brent. So we are really glad that we can help out by hosting this event on our corporate conferencing systems. Just a few words about us. So we are a startup company in Santa Clara. We are developing electronic autonomous multi-purpose vehicles for enterprises and municipal usage. So we have developed a mobility platform that can provide cities, airports, industries, and the like with full autonomous working vehicles that reduce risks and cost for operations. Yeah, so you can get better sense of what we build at our website, www.zico.com. Spell it out, ZWIIKO.com. Thank you very much for the opportunity.
Great, thank you, Yao. So we had Avida here for a minute, and then she disappeared. So I'm going to, oh, there they are, there she is. Great. So, great. So Chen Ping, I don't know where he is, but I suspect he will make his way. This will not stop us. We will pass forward. So what I would ask is, Avida, why don't you say a few words about your work at UC Berkeley and as the Qualcomm chair, particularly relative to AI and autonomous vehicles. And then we'll give Mohammed a few chances to talk about his work as well.
Sure. So my name is Avida Zokor, and I've been a faculty member at UC Berkeley for the last 30 years or so. The last, I would say, 20 years, or I've been focused on various mapping problems. So from about 2000 to 2007, outdoor mapping, fast automated ways of mapping cities. And then from 2007 to about 2017 or so on indoor mapping and indoor positioning, indoor localization. And the last 3 years, I've been involved with, I guess, autonomous driving and various ways that sensor fusion can help with both mapping, also object detection, etc. The two projects that I'm leading right now have to do with using temporal LiDAR data to do object detection using AI techniques. So by temporal, I mean take advantage of the sequence of LiDAR frames that's coming at you. And also trying to use unsupervised or self-supervised methods to predict future LiDAR frames or to predict future video frames. And also unsupervised depth estimation using video sequences. So those are the three areas that I'm working on now.
So you're trying to say you're a little bit busy.
A little bit, yeah.
Great. Well, thank you for joining us. And Mohammed, can you give us some insight on your work at Deepen AI?
Sure. Hi, everyone. I'm Mohammed Musa. I'm founder and CEO of Deepin. We work specifically on a lot of sensor fusion related challenges with autonomous driving. And we do three things like our company logo says. Let's see if I can curate, annotate, validate. So essentially selecting the right data for training and validation of your AI system. And then we do all types of annotation required, both providing the tools to do the annotation or providing the service. We have a team in Hyderabad, India that can do that, and a number of partners who can provide the workforce. On the annotation piece, we kind of focus a lot on what Aviday mentioned, LiDAR sequences, sensor fusion mixed with camera, radar results, and so on. And the specific problems we look at are around detection, classification, segmentation, and tracking. Prediction is part of it, but you cannot annotate what the prediction is going to be. But because we have access to the time domain, we can actually look ahead and look behind to optimize the labeling process, and that helps us make the process a lot more productive and less costly, obviously. And on the validation piece, that's where our company differentiates from a lot of annotation providers in the market. Is we focus on autonomous driving safety, and we've been working on categorizing a lot of the dangerous scenarios that can occur to the autonomous vehicle in the various operating domains where it's expected to operate. And we started an initiative called safetypool.ai with the World Economic Forum, working closely with a couple of governments on safety regulation of AVs, on what is the role of AI in basically helping us come up with a safety framework for quantifying how well the autonomous system is operating. And I guess we've worked with a lot of the teams here in the Valley, as well as automotive OEMs and tier 1 suppliers across the world, Japan, Europe, etc. I think Chenping is here.
He is here. He was having some trouble. I don't know if I will ask him to start his video and we'll see what he says. He's muted.
Sorry, I'm actually just getting to the office. I'm on a car. So for now, I'm going to have the video up. I'll turn it on in about 5 minutes.
That's totally okay. Are you good to say a few words about Fire and your work in the AV and AI space?
Yeah. So I can speak. Yeah.
Great. Have at it. Oh, he's on mute. Unmute. Clearly, there are a few bugs still to be had in this system.
Yeah. Sorry about that. Yeah. So can you guys hear me now?
Yes, we can.
Great. Cool. Great. So happy to be here. My name is Chen Ping. I'm the co-founder, CEO of Fire. What we've been working on is what we call AI-powered AR navigation for driving. What that means is right now, most of the people that drive uses some kind of a GPS navigation system, and whether it's Garmin, TomTom, Google Maps, Waze, Apple Maps. It's very clear that it's a must-have for all kinds of drivers, any kind of drivers. But the thing is, we're still using a 2D map to show us how to get to our destination. And for us, what we're building is to make that augmented reality. We show the directions of where you're supposed to go by overlaying the route onto the road, onto the lane. So with a quick glance, the driver knows exactly where where he or she is supposed to go. In order to achieve this, we need to build AI that understands the road for us. For example, where are the lanes? Lane detection, semantic segmentation, object detection, and also 3D localization. It's very similar technology as self-driving cars, because if we're showing you which lane and how to drive to your destination, in theory, if we have control of your vehicle, we can also just drive for you by following that route. The difference is that in order for us to deploy this to the mass, we need to build it on the device that everybody has, which is a smartphone. And that means we have to make our AI very, very efficient. that can run on a smartphone without overheating your device and still giving us good accuracy that can run in real time. And so that's a challenge, specifically for our use case. But overall, yeah, our application is AR navigation, which is very related to autonomous vehicle.
Cool. All right, so we look forward to when you get in the office and you're able to jump on the on the video with us. That will be awesome.
Sure.
So let's get into the panel discussion. So I'd like to ask our panel here just a little bit about how AI is being deployed in autonomous vehicles today. And I know that's an open-ended question, but there's a lot of, when you think about what Tesla's, when you think about what Waymo has going on and a lot of the partnerships that are taking place, I think we talk a lot about perception systems and LiDAR and cameras and that kind of stuff, but AI continues to be kind of that dark secret that lurks in the background that nobody really understands. How is it involved? Is it involved? Where is it involved? What can you all tell us about that? Avida, you want to start?
Yeah, sure. So I think the object detection is kind of where my mind goes when you say about where AI comes into place. Basically, there's the perception, and then from there you feed that to the autonomous driving or the control planning and control aspect of the system. And so to be able to do that, you need to be able to detect stationary objects, moving objects, not only objects that you might bump into because they're stationary, but also objects that are moving and their trajectory might come close to where your trajectory will be in the future, which is a much harder problem. So the 3D object detection is really to me, the crux of the problem, and there's a whole variety of deep learning methods that people apply to solve the problem. What my worry is that we're not, at the moment, we're nowhere close to having a safe enough or high enough detection rates and accuracy in these AI-based systems to really take the driver completely out of the loop. We all know that having a driver next to the autonomous controller is a bad idea, because we as humans, it takes us a while to get engaged and correct the mistakes that the autonomy algorithms make. So, but at the same time, we're not quite ready to 100% let go, because the error rates, even if they are 95% accurate, if the error rate is just 5%, that's way too high. So my worry about this whole idea of 100% autonomous driving is the AI systems and the deep learning algorithms are not robust enough, and there's also they're not robust enough when there's no adversarial attacks, but then when there's adversarial attacks on them, it becomes even more of a problem. A small change in the stop sign will make you not be able to recognize it. Is a pretty big disaster.
Mohammed, what are your thoughts?
Yeah, so Avida is exactly right. Most of the systems today use AI and coupled with traditional computer vision algorithms to be as a backup. And what you end up having is 2 or 3 different independent systems that give you input on what's happening, and then you can kind of decide if what you're seeing is exactly what you think you're seeing. And just kind of to come back to your question around where is it used, so it is used. Tesla announced publicly in multiple conferences that they're using more than 60 different neural networks as part of their autopilot system, mostly focused on perception, which is the problems I mentioned before: detection, classification, segmentation, and tracking. And they haven't said that they are using it for localization, but localization is also a big area where neural networks can do a good job. Like Avida said, it has its own failure modes, and there are some algorithms that you can use for, especially with LiDAR. Actually, a lot of the systems that use LiDAR is almost entirely for localization. And if you think about the other aspects, like mapping, voice in the car, and so you're talking to the assistant inside the car. Mercedes has Hey Mercedes, and a few others. And even you'll see some projects around predictive analytics. So they look over the car data and try to predict if there's going to be a malfunction, and to give you a very early warning that you should go and check this out before it happens, and so on. So there is a lot of AI use today that is happening. I think when you think of the entire kind of level 4 fully autonomous system, AI is just one way to solve the problem, but it's not at the point where the robustness and reliability is enough to say, yeah, I'm just going to use neural networks for everything in this car and I'll be fine. That we're nowhere near that, and I don't think we'll ever be. Actually, it will always be a hybrid system, and also kind of depends on what you mean when you say AI. Does it have to be neural networks? Like, is a classical clustering algorithm or feature-based extraction from images, is that AI? It is computer vision, but it's not neural network. So I think once you distinctly or clarify what you mean by the words, then it can include a lot more that we can think. Even for gas consumption and ICE engines with a combustion engine, there is a ton of AI being used to make the car more economic, and switching between hybrid and electric engines and so forth.
Shenping, do you have any thoughts on this? Looks like he's...
Yeah. So it's very interesting to hear from everyone about the thoughts of how AI is being used in autonomous vehicles. I think for us, we see that AI is really important for lane segmentation, object detection, semantic segmentation, for us to understand what's around the vehicle. But the thing is, like everyone mentioned, this is very difficult for us to make it very robust to take over all the actions for the humans. And I mean, so many big companies such as Google, they promised self-driving cars to be out by, I think several years ago, they said 2019. Obviously, we passed that already. So people are starting to realize how much work is needed to build self-driving cars. And therefore, I think in terms of startup world, self-driving car related startups are feeling that kind of decline of interest. So people are also having trouble raising funding because of that decline, whereas versus several years ago where it was very hyped up. I think it's definitely going to take a gradual rollout. So instead of self-driving car taking over the world, it's going to take years of gradually moving toward fully autonomous if we can ever get there. But I think given how popular AI research is going in academia and in industry research labs, I'm actually pretty optimistic about the reliability improvements in AI, because so many people are working on it. I mean, the speed of advances, it's amazing compared to several years ago when I was still a PhD student. So when I was doing my PhD, so I graduated my PhD in 2016. So what happens is half my PhD was in deep learning. The other half was traditional computer vision. I remember during my traditional computer vision time, the advances in computer vision AI was so slow. Every time you get a paper saying that they achieved state of the art by maybe 0.5% or 1%, it's just those little bit of numbers. But after deep learning, things starts to speed up really quickly. And even now, there's so many advances going on that's much, much faster than before. So while we're not yet there for sure, but I'm quite optimistic about the reliability because so many people are working on it.
But I think that's a great point, right? So I just want to get clarification from everybody here on your thoughts. Is it that the software, that the AI isn't there yet? Whether is that processing speed? It just can't, like the edge processing isn't fast enough to categorize, identify, you know, path plan, all that? Or is it that the hardware isn't there? The cameras, the LiDAR, the radar, the sonar, etc. We just haven't found that magic bullet piece of hardware that is going to give us, that's going to eliminate that 5% that Avida was talking about. Or is it both? It's the algorithms.
I think the sensors are there. We can get all the bits. And I think with enough time, hardware will be there as well. But I think it's the software. And I like to build on top of what Champing just said, which is, it is true. There is a large number of people working on it. But if I may say so, is that as time goes on, there's a little bit of a, I guess, bifurcation going on in two different directions. You've got the organizations, companies that have big computing resources. I mean, by big, I mean like hundreds and hundreds and thousands of GPUs running at the same time. They have an edge over, I would say, universities, or they're beginning to have an edge over universities in terms of making headway on these problems. I'll just give you an example. One of my students went to a summer job. I won't name names. And after he came back, I said, well, would you like to continue on what you were working before? He said, no, when I was at this summer job, I had access to 1,000 GPUs simultaneously to run my simulations. And at Berkeley, you don't have 1,000 GPUs in your lab. You have 20. And mind you, I had paid close to $20,000 per machine. So it's, you know, for university, it's a substantial investment, yet we just can't catch up. So there's a computing imbalance, I would say, that's growing. And then, and really, it's really the top 5 or 6 tech companies that dominate in that space. And then there's the data imbalance, right? The more, you know, the best models that come out are usually the ones that have been trained on 100 times more data than we ever have access to. And then the combination of data and computing makes the thing even more compounded. If you have a lot of machines and if you have a lot of data, then your models will be a lot better. And so I think at the end of the day, it becomes the idea, it's no longer a matter of who has a better idea. In the classical computer vision era, let's say 10 years ago or 20 years ago, it was like, who thought of this clever idea to make the math work out? And so everybody had a chance. The best minds had a chance to dominate. Now it's more a matter of, well, how many thousands of GPUs do you have? And how many terabytes of data do you have? Okay, let it run for like 3 months. Okay, then we get a model. And by the way, we're not going to publish that model. Or if you publish the model, we're not going to publish the code that produced that model, because that's my technical advantage over other people. So that's what worries me about this field. It's no longer a democracy. It's become a big money dollar game. Whoever has got the biggest resources is going to have the best models.
And that's actually pretty scary, because you're not exactly talking from Lewis and Clark University. Like you're UC Berkeley. So if Berkeley has these problems, the rest of it.
I don't say we have a problem, but it's just an observation, right?
Yeah. Challenge that.
Right.
Yeah, I can definitely resonate on that point. I think that was a reason actually also why I left academia. I did a postdoc. Usually computer science PhDs don't go for a postdoc unless they want to go into academia. But I did, and I quit halfway for entrepreneurship, partially because I was getting very, very depressed about the lack of resource. I mean, you know, schools never lack a resource. It's just compared to the big corporations, it's not comparable, because they have so much money. They're throwing all the resources in. They're grabbing all the smartest students out of university. So they're also draining academia from the fresh new academics that were going back in, but now being drawn out because of the crazy size of paychecks. And also, I think not just in addition to, of course, thousands of GPUs they have, they also have a lot of data that, you know, in academia, we rely on public data set to perform research. And a lot of times we build our own data set. But ever since Google, Amazon, Microsoft, they got into the game, if you look at all the latest research and data sets, it's starting off from the industry labs. I mean, I think so far from my experience though, we are still able to find their latest models that's being published on the TensorFlow. Not all of them, but I think a good amount of them. But the other thing then is, I think, like Avida said, that the idea is no longer as critical as before, because, you know, when those big places have all the greatest minds, all the young, old, whoever, the greatest minds of all ages there, they kind of just take over all the innovations, advances in publications also. So for example, 3 years ago when we started our startup, we focused on efficient AI, meaning running everything at the smartphone level, making very good trade-off of accuracy and efficiency. But then, you know, Google started to push into mobile net and all the mobile dev, all the efficient mobile designs of AI. When they have hundreds of people working on this, you just cannot catch up anymore. So nowadays we kind of be like, okay, so I guess we rely on our know-how to know which ones out there is good for us. But it's yeah, I definitely can resonate about the big companies having all the resources. That kind of makes everything.
I mean, is it so different from? I mean, or are we destined to follow the path of like the smartphone, right? Where it's not like there are hundreds of smartphone companies out there. It is dominated by the Samsungs, the Apples, you know, largely just even those two players, with Google coming in at behind. And you have some fringe players who are trying to get market share, but just the vast majority is dominated. And Samsung has tens of thousands of engineers that they throw at this. So is that just how product development happens in our country or even globally? I mean, should we expect anything different?
I think for us, we work on smartphone. It's because that's the device that everybody has. Not that it is our preferred device. We don't prefer you looking at your smartphone screen for AR navigation. That's because we have to. We of course are looking for AR glasses to be the next wave, which is going to still take several years. But ultimately, we want our algorithm to help self-driving car technologies to be lighter weight also. So that can make us an important player in that ecosystem. But smartphone, I think, I definitely don't see AV technology taking off on smartphone, because that's not meant for this use case. It's more like an interim device that we're looking at.
Well, no, I know. I was referring to the model, right? Where early days of smartphones, you had a lot of players that were trying to put out devices, and because of just sheer the weight of engineering innovation, we now have a very small field of players who dominate the smartphone market. And should we expect any different in the AV space, where you've got a bunch of startups, but you've also got these Goliath players that are, like you said, consuming all of the talent, and they're getting all of the data, and they're able to innovate so much faster than the other players, that we're, you know, should we expect to see a consolidation where at the end of the day, you know, there really are only 2 or 3 main players in the AV space?
I think part of it also has to do with, part of the consolidation happens because these big companies acquire a lot of the small companies. You know, 30 years ago in Silicon Valley, you would do a startup because you wanted it to go IPO. Now, when you talk to founders, you say, I'm doing a startup because I want to be acquired by the big 5. So it's just affected the mentality of how we think. And so that, to me, that's a little bit unpleasant and a little bit dangerous, because I do remember 30 years ago when I started in the Bay Area, it wasn't the case that you start a company to be acquired. So part of the consolidation is because even if you are a startup with a really good idea and survived despite not having thousands of GPUs and terabytes of annotated data, even though you survived all of that, well, the next thing you know, you get acquired, and then you become part of that those other big organizations. And so, and if you think about it, traditionally, how did we deal with this? The one time government intervened, it was in the 80s. They broke up the AT&T and the telephone company into pieces. And occasionally you hear the same thing. I know we're diverging from the autonomous driving business, but you hear the same thing, antitrust laws getting invoked on the big five, and they're getting too big and too powerful. But I'm not really sure if that's the right solution, is to take their power away, because that could backfire in 5 different ways that we didn't think about. So it's a hard problem.
Yeah. So if I can throw out maybe a ray of hope, right? If software is the problem, very often the breakthroughs in software come from approaching the problem from a different perspective. And my experience has been that startups, especially students coming out of these universities and whatever, have a key advantage in looking at problems from different perspectives. And even sometimes it can be a mistake that is just a happy error that suddenly increases the viability of the algorithm exponentially. So is there hope yet that we can still grow an ecosystem?
Remember, we're still in a nascent space, right? How many fully autonomous vehicles do you see on the road today? 0. So
sorry, Zeus.
Yeah. So essentially, the number of players in a very expensive, very ambitious technical goal, it's by definition hard to do. And then there will be very few players who can play at it. And if you look at the consolidation that happened, we probably ended up with about maybe maximum 7 real participants in trying to attack AV as an end-to-end solution. And the 3 guys, three of them are really big companies. Google's there, Amazon is there, and so forth. So because it's such an expensive undertaking, mapping the hardware, the software, and then kind of a lot of the problems that Chen-Ping talked about, you need to run on the edge, and you have to be power efficient, and you're running on an electric battery that you need to maintain for a long time, and you're not going to run 1,000 GPUs on your car. Actually, even just one was too expensive for Tesla, so they had to make their own chip to run autopilot on. So you have to look at all of these factors. I think once 1 or 2 players figure it out, there will be a path for democratization. And we know, like ROS is the robotics operating system, is pretty much used by everybody, and it's an open source project. And there are companies like Apex who are working on a functional safety version of ROS2 that will also be open source, and then will be deployed with services and capabilities that they're selling to the OEMs and so forth. So ultimately, I see a path for more sharing and more openness down the road. But when you're in a pre-competitive market where nobody really has yet achieved the goal, it's hard for people to share their data. It's hard for people to share their hardware or reference designs and so forth. And that was kind of actually exactly what we did with Safety Pool. We said safety is not something that you can compete with, especially the basic level of safety, right? Like when you look at driver assistance functionality, you can say, oh, I can do lane keeping, or I can do collision avoidance, or I can do automatic braking. And each time you add a new feature, you say, hey, my product is more competitive because it can do X, Y, and Z. But when it comes to autonomy, a lot of these things that you were competing against in the ADAS, in the driver assistance world, become sort of absolute must-haves. It's like how you define if your system is able to function safely or not. And with Safety Pool, what we convinced many players is that the safety scenarios that you use to certify your system is something that you can share with the rest of the industry. And us as society, we should know what we can expect from a technology that is nascent, so we can deal with it properly. And unless you have that transparency of the understanding of the technology between the people and the companies who are providing it, you're not going to get social acceptance. And then if you don't get social acceptance, you know, the tech is going to die and nobody's going to care. If you think kind of the three factors that people care about is convenience, cost, and availability. You know, how much you're going to wait for your car. Is it convenient? Is it clean? Is it safe now for me to get into a vehicle that maybe somebody that had COVID was in it? You know, so all of these questions are tied together. But like before we answer a lot of them, we have to solve the technical problem. And some sharing is happening. It's not, you know, as open as other fields, but it will come. We have to be patient. It is like a moonshot, you know, like getting to the moon. How many universities landed on the moon? Not zero. So it's like that. I think it is just the sheer ambition of what we're trying to do is the reason for that.
Fair enough. I mean, I wonder, since no one wins unless we get to L4, L5, right? No one wins the autonomy game. We don't have robo-taxis or anything like that until we get to that point. It strikes me as someone who, you know, lives and works in this kind of ecosystem, that there isn't more collaboration to get to that point, and then we can play the competitive game, right? But let's at least get to that point. And so I'm curious, what are your thoughts on, are there emerging types of AI that are going to help us get to L4 and L5?
I mean, Avide would probably know more than I do, but in unsupervised learning and in reinforcement learning, there's a lot of promising aspects. They're not at the point where they're production ready, maybe many years behind, but maybe I'll refer to you, Avide. What are you seeing?
Yeah. I think that overall, we still are making steady progress. We haven't reached the plateau or saturated. We're still trying to figure out the best representation for the data. We're still trying to understand the robustness of these systems. So I think Chen-Ping was right. The rate at which we're making progress is phenomenal. It's really good. And what's to me, what's missing is our systems that can provide you with some sort of a guarantees. Guarantees in terms of error rate, guarantees in terms of, you know, catastrophic answers. You want to minimize the possibility of getting a really bad answer, kind of a thing. You know, I don't want to be pessimistic. I think we're not there right now, but it doesn't mean we're not on our way to get there. So the question is, how many years is it from now? And when will we reach a stage where when there's these autonomous cars, we feel safe going out in the street? It's kind of like with the COVID. When will the vaccine come that we get it? Then you feel safe going out into the masses, right? The same thing. That I don't know, because yeah, I mean, we can teach as many rules as we want to autonomous cars, but there's some unwritten rules that it's in our heads, and there's protocols that are not written for driving. And so when will we reach a point where machines understand those unwritten rules as well as we do. And they don't get fooled by small perturbations in their input. Right now, what worries me also, one of the concerning things is adversarial attacks. If you just perturb the images and the sensor data coming into the machines, they make drastically different decisions, and that's not good. Also, when you think about 3D object detection, unfortunately, the highest error rate is for detecting pedestrians. Why? Because they're so small. Cars are big, trucks are big. The car will never bump into buses and trucks, but it could run over pedestrians very easily. And then testing everything under all possible conditions, all possible weather condition, lightness, dark light, etc., rain, snow. So there's a lot of nuances to it, and I think what will happen in the future is we'll have mini demonstration projects, and there's some of those already, like autonomous cars in campuses of companies that drive you from point A to point B, and then this is like crawling. Then from there we go walking, and then from there we can go running. So it'll come in many stages. It won't be like tomorrow you wake up and there'll be an autonomous car driving you to work or anything like that.
So that brings me to the next question, which is, what do you all see the goal for AI enabling autonomy? Is it to get to where you can't tell the difference between an AI or a human? Are we trying it, like, is human driving the benchmark that we're reaching for, or are we trying to far exceed the human driving benchmark?
Yeah, I think human driving is a very low bar, right?
A low bar we haven't reached yet, apparently.
Yeah, but you have tens of thousands of deaths happening on an annual basis. The way I think of autonomy, it's enabling, well, one, more safety, right? So we want to save more lives. Second, we want to make it more accessible. Mobility is almost a human right. Like if you underprivileged or communities with economic disadvantages that cannot afford cars, cannot afford Uber or Lyft because they're so expensive, with AVs you can actually bring the cost down and enable mobility to a lot more people. So that's what motivates me about AVs is safety, productivity, and access, more equitable mobility access to a lot of segments of the population. Your kids now are not able to mobilize because they need an adult to drive them, or if someone is disabled, the type of car that can take them around is a lot more expensive and it's not that available, and so on. The productivity piece is where we will see a huge boost in economic value that comes out of AVs in general. When you're not paying attention to the road and driving, you can read, you can sleep, you can work, you can study, you can do a lot of productive things. So there is a lot of economic benefit that we will derive out of it. I think there is no question that if we get this thing right, it will be awesome. But getting there is hard.
So this is there was actually a question that said, given the safety and standardization concerns, shouldn't the government step in to force companies to share their models and data?
That is a very sensitive, not the right word, but I think, I don't know. I think that's making us to sound more like China in a way. I mean, I can see the rationale there, but there's probably a more gentle way of achieving similar effects. But for sure, in terms of safety and human level, I think human level it's actually broad. It consists of several different factors. For example, if you just say is humans smarter than computers? It's similarly as saying, are human drivers better than computer drivers? But in terms of smart, there's different aspects. For example, we are not as quote unquote smart in terms of memorization than computers. We're not as quote unquote smart as pure arithmetic computation as computers, but we are smarter than computers in other ways. And therefore, if you look at self-driving, it's the same thing. There are certain areas where we do better. For example, we can recognize things so much faster, more accurately, but maybe our attention span, our focus of attention is not as good as a computer because we look at a certain spot once. Our eye moves fast, but it doesn't cover everywhere. I mean, I think one interesting feedback that we got earlier was that we were detecting, for example, we're showing our safety warning system by detecting pedestrians coming from the right side in crossing a street. And then people would say, but that person is so close to you, why do you need an AI to detect that? But they don't understand. What they fail to realize is when you're driving, a lot of times you're not even looking at your right side, you're looking to your left. Sure, you can see the person to your right, but you're not paying attention at that person. So, you know, there's many aspects of where computers do better or worse than human drivers. And I think maybe one way of looking at how to achieve fully autonomous driving is not to treat a single self-driving car as an entity to make that entity super smart, but to really utilize a group of them, a network of them. For example, you know, even if you have the best sensors, you could still miss the person that's 200 meters in front of you, misdetected. But if you have another self-driving car that's closer to that person, which detected it, and all the self-driving cars talk to each other, then that information can be aggregated and communicated with the network of cars. So I think that's where the network of AI agents communicating with each other could help. And I think we just need to find ways to continue to augment what the AI is missing, instead of thinking maybe we need to make the AI perfect, but use other ways to augment for deficiencies, to achieve the applicable, to achieve the autonomy that we want to achieve. Yeah.
I can't tell if Avida is skeptical or hopeful. I don't know. She's got a bit of a poker face there. I can't tell.
No, I think this idea of network is good, and what it got me thinking is that you can also add infrastructure to our streets and highways and freeways to prevent cars from doing disastrous things, right? So even if the autonomous driving car didn't quite detect the pedestrian, maybe there's sensors on the lamppost or on the traffic lights, or even aerial sensors having top-down bird-eye view could be able to intervene when disasters are about to happen. That could be kind of like another way of doing it. You know, this is a low delay kind of a problem. Things happen in a split of a second. Decisions have to be made very quickly. So again, a lot of corner cases need to be ironed out for the whole thing to work.
Mohammed, you got any thoughts here?
The network there's a lot of value, but it's a can of worms. Network packets can be easily spoofed, manipulated, and from a safety critical system that can cost people's lives, I think the rule number one is that the system should be able to figure things out on its own without relying on any external sources of information. So it's a trade-off. You know, obviously, if you have perfect security and then you can reliably rely on information from others, sure. But it's a challenge. So it's still an open area. So, you know, there's more solutions that are being suggested, and I think infrastructure as well as this car-to-car and V2X, which is, you know, vehicle to everything communication. All of these things can enable a lot of things, but they also they're not like slam dunk wins where we can just like, yeah, you know, we're gonna put a LiDAR at the intersection and it's gonna tell everybody what's hidden and what is the velocity and detection of the things that you're not seeing, and then like we cannot call it a day and say problem solved.
So last question that I have, and then we'll try to dive into more of the Q&A. What has your greatest insight or learning since you started working with AI in the autonomous vehicle space? Chenping, we'll start with you.
I think you broke up for just a second. Can you repeat your question, please?
Yeah, the question is, what has been your greatest insight or learning since you started working with AI in the autonomous mobility space?
This is a really interesting question because I can think of different answers by looking at it from different aspects. For example, from the entrepreneurship aspect, I definitely also resonated from what Avita said, that the goal for startups used to be, AI startup used to be IPO and really go public. But and the conventional wisdom is that you don't want to create a business with a technology looking for a problem to solve. You want to solve a problem. You want to know which problem you want to solve, and then your technology helps solving that. But nowadays it's kind of that's still true, but especially for AI startups, I think a bunch of researchers and students or scientists, they're doing startups with a technology and then trying to find ways to solve it, which still and given today's landscape that works. For example, there's this startup called XNOR.ai that was recently acquired by Apple for I think $200 million. If I remember correctly, their team was the authors behind the seminal object detection paper YOLO. So after YOLO took off, they just like, hey, let's go to a startup. I mean, what do? They're just kind of monetizing off of object detection, but not really a problem to solve. So they were looking for a problem to solve, but it doesn't matter. Apple in the end still bought them $200 million. Investors are happy, and so I definitely resonate on that statement. So that's one of the insight that I've learned right now, is that because for our company, we've been focusing on that, hey, we're not using technology to find a problem. We see a problem, people using 2D map, making wrong turns, and it's dangerous because your eye's off the road. We're solving that problem by showing more direct information. But I guess people care that less than when they ask you, what is your killer technology? So I think that's kind of the biggest insight I'm finding now, is that maybe we don't need to care about the problem we're solving that much, given today's landscape. We should just kind of turn our team into a research lab almost, just to churn out more technology. Yeah, that's just one aspect of looking at this question. Yes.
Okay, who wants to follow up on that one? Mohammed, what do you think?
I think number one learning for me was not to take rejection seriously, and whether it's for an investment or a customer or a person you're trying to hire or a partner you're trying to work with, because things change, and they change in major ways. If you look at the autonomous landscape between now and 5 years ago, like 5 years ago, Cruise was still a startup. Now it's a multi-billion-dollar DM entity, right? And Zoox was a startup trying to reinvent the whole thing. Now it's part of Amazon, or if it closes. And Waymo was something, I used to work at Google, and it's very different, their goals and their objectives, than what they stated publicly a few years ago. So things really change a lot. And what the reasons you hear that people say no to you today, it doesn't mean that you're wrong. It means that maybe you know something that they don't, or you believe in something that they don't. And we've had instances where we worked with customers that told us to get out of the room when we first pitched them, right? And now they're customers. So it's important to kind of focus on what you're trying to achieve, and be persistent, but without being arrogant. so, listen to what others have to say, but know that the world is changing, it's changing fast. So like nothing you can say, especially when you see these star, hero type characters that you go and talk to them and they tell you something. The next day they may change their mind and say the exact opposite. So exercise a lot of judgment and stand your ground. If you know you're doing something right and for the right reasons, you should stick to what you're doing, and hopefully God will make it work down the line. It doesn't work for you when you're wrong, but when you're right, it does beautifully.
Avida, what's been your greatest insight?
One of the things I've kind of shifted away from is solving problems that require a huge amount of annotation. I'll try to stay very technical. So over the years, I see myself gravitating more and more towards self-supervised or unsupervised methods where you just throw at it data that does not need to be labeled. Again, in academics, we're disadvantaged because we don't have a lot of resources to annotate data or huge amounts of data. So one trend that I see in my own work is just focusing more on that. And there are, like when you look at video or temporal data, the next frame is a great self-supervision signal in order to help you figure out whatever you want to solve. And to that end, there's been a lot of progress in this general area of computing ego motion, computing depth, computing optical flow, all in a self-supervised way. But more broadly than that, another area that I think that has inspired me is really trying to understand how the human brain deals with all of these complexities. When a child, and especially children, when a child is born, we don't give them a million training and annotated examples and say, now tell me which one is the giraffe and which one is the cat. And with very few examples, they learn. And so how do humans do it? So there's a lot of, in my mind, there's a lot of inspirations that we could get from both studying human behavior and human cognition and children and the brain structure, all of that, in order to help us crack this.
I want to follow up on the brain, human side of studies. I absolutely agree. I think, we have the perfect, in a way, perfect in terms of what we want to achieve system right here. But we're not drawing enough insight from it. There are neuroscientists, there's cognitive scientists, psychologists learning it. However, there is just such lack of collaboration between AI, computer science AI versus human intelligence, cognitive science field. Because I think there's a stigma that if you're not doing hardcore statistical formulas, a lot of times people feel that, oh, if you're doing a brain-inspired AI, you're kind of less technical and therefore being less respected. At least that's how I felt coming out of the studies, because I was actually co-advised by a cognitive scientist when I was doing my PhD. So I felt a lot of that, and I think because of that, computer scientists, they stay in AI doing hardcore mathematics, statistical learning, deep learning, whereas cognitive scientists, a lot of them, they want to become more technical, but they just don't have the same kind of background training that allows them to be as technical, and therefore there needs to be collaboration, but the collaboration is not nearly enough. But if there are enough collaborations, I believe definitely that can help propel in a different way of thinking of getting our AI to be even better. So that's something I'm hoping that the fields will evolve more into.
Okay.
One comment to Avida: we can help you reduce the cost of annotation by a lot.
Oh, that would be fantastic. I'll call you tomorrow.
All right. So we have a lot of questions that are kind of lined up here, and what I'll do is I will share the list of questions with all three of you, and then and let you kind of respond to those, and then I can post those answers on the meetup in the notes. So everyone who has asked questions, I will seek to get the answers for you, and then we'll post it on there. But I always try to keep our meetings on time, and it's 5 o'clock. So the lightning round question, I love asking people this because you always get a different answer. When will we see level 4 vehicles on the road that we can actually, request with an app? Mohammed, what's your answer?
Say that again.
So when will we see actual level 4 vehicles on the road that you can request a ride with, right? And not with a safety driver. Actual level 4 vehicle pulls up, you can get it, just you, and it takes you to your destination. Basically what was promised, I don't know, 5 years ago. Mohammed might have frozen, or he's thinking.
I think Arizona now.
Okay.
Yeah, where? Can you hear me?
Yeah, we got you.
Yeah, I think my connection is becoming unstable. My answer is if you reduce the domain of operation enough, you can do that today. There are startups like Voyage who operate in retirement communities that can do some level of autonomy. Waymo obviously has been given level 4 rides without a safety driver in Arizona for a while now. It is 100% from your app. You can call it and it comes to you and it takes you to where you want. Now, if you are saying like, can we see it everywhere? That's a lot harder question. The more constraints you put on the problem, the better we can, give you a targeted answer. So there is, in some ways, yes, you can do it today in certain cases. And if you want to cover kind of a level 5 anywhere, anytime, I think it's never going to be economically feasible to get to level 5, which is the same car can drive anywhere, anytime, fully autonomously. It's just not economic. It doesn't make, there's no use case where that's really beneficial. All
right, so I'll qualify it. How about San Francisco cab substitute?
Yeah, we have to ask our friends at Cruise.
Yeah. Avida?
I'll throw out a number. I'll say 2025.
2025?
I think under certain constraints, we could be able to. I mean, under some, for example, in China, I just saw a video where you can already request DD self-driving services at select regions. That's very tightly controlled and well tested. So I think, yeah.
Okay, Avida?
I was just looking at the chats that popped on my screen. So to reflect what they said, the lawyers have to agree, the insurance companies have to be happy. So there's all those non-technical aspects that obviously have to be addressed. Who's liable when you have an accident, that kind of thing. But setting those aside, I'd say just for the narrow example you said, San Francisco. Actually, San Francisco is a bad example because we have so much fog. Maybe somewhere not so foggy as San Francisco. Daytime, cab, I would say 4 or 5 years from now. I was going to make it wide, technically speaking.
Okay, so maybe San Jose.
Yeah, better, more sunny, right?
Right, 4 or 5 years.
I'd say so,
okay.
Yeah.
Okay. Well, guys, this has been great. I'm really glad, Chenping, you were able to make it to the video. And I'm really grateful that you all shared your insights with us today. We have been recording this, so I will get that wrapped up and ready to share as soon as possible. And I will also share out to you the questions that we were not able to get to, and see if you've got some answers that you can share and provide your wisdom to the group. And I want to thank all of our attendees that attended today. I hope this has been useful for you, and check out the, keep in touch with the meetup page, and I'll be posting our next event as soon as possible. All right. Thank you, everyone. Have a wonderful afternoon, and I hope you have a good weekend as well.
Thank you, guys.
Thank you. Bye-bye.
Take care.